Hello and welcome back to the engineering drawing course. In the previous section, we have seen the introduction for this course. Now in this section, that is review and basics, first I will be giving the definition of engineering drawing, then later on I will be giving you the list of instruments and other criteria for approaching this course. So we will start with what is engineering drawing. So, what is engineering drawing? Engineering drawing is a type of technical drawing. This means that engineering drawing have a purpose which is different from the artistic drawings. Like for example, if you paint a horse or a house to show to someone that it will look good or something. But engineering drawing has a different purpose. It is used actually to show the full dimensions, that is the size or shape, tolerances, other necessary information which is required by the workers, that is floor workers or the construction workers, for completing a project or manufacturing an object. So in general you can say that engineering drawings actually convey the idea from the mind of designer to the floor worker. Let us say one design engineer have designed a product, but to the floor workers he cannot just tell in writing or with a word of mouth. He have to give this idea to them in the form of drawings. These drawings are drawn by using the rules of engineering drawing in such a way that this can be interpreted all around the globe. So in simple words, we can say that engineering drawing is a language of manufacturing and architectural engineers. That is why it is extensively used in the field of manufacturing and construction. So now we will see two real life examples where we will first start with the engineering drawings. So take example 1. See here that our design engineer has imagined a mobile phone case cover for a new model. Say this is the mobile phone cover. In order to describe this cover's dimension and specification fully to the workers or supervisors who are going to manufacture this on the machines, the CNCs or the numerical control machines, the design engineer should give the design in the form of drawings, that is 2D and 3D views. These are actually called isometric views and 2D views. We will see now. Let's just see its three-dimensional views in this video here. As you can see here, I'm rotating this video. So your mobile phone will fit inside this cover. You see the micro USB port here, and you can see here USB charging above, and the hole for the provision for the camera, and this is the provision for power button, and this hole is for the headphone jack. So this is a basic design of a mobile phone case cover. Well, this looks good on this video and on this paper here, but it's missing a lot of details in here. The depth of these holes and the curvature of this motion. So for that reason we have something called isometric views. This is called the isometric view, and this is called the orthographic projections. This is actually the front view of this cover, as you can see here, and this is the bottom view, and this is actually the top view. This is the right hand side view, and this is the left hand side view. You may get confused here because this is the left hand, but I am saying this as right hand side view. We will discuss about orthographic projections in section number 3, that is next section completely, so don't worry about it. For now, you need to observe that this is the form of drawing which the design engineer will provide to the floor workers for manufacturing it on the machines. So this is called the isometric view, and this is called the orthographic view, that is the 2D views of this mobile phone case cover. So we'll see one more example. For example, an architectural engineer or a civil engineer is going to design a plan of a house on an empty land. So in order to show the client or the workers the main features and dimensions of the of this house or the plan, he has to give the complete specification. Like, see that this is an empty land, and this is the imagination of your civil engineer. Let's just say he has imagined something home like this. This is the gate, and these are some rooms. So this is the gate, this is the entrance of this house. Gate, toilet, living room, bedroom. This is the kitchen. Now this is the imagination of the civil engineer. So now you can just take a look at it. This is the gate, this is the toilet, and this is the living room. It's just a small piece of land. I just wanted to give you a small example here. That is why this is a basic simple, and you can observe doors and windows here. So this video looks good, but this cannot be given to the workers or the client. The civil engineer will design a plan something like this. So just observe here, make a relation between these two. Like you can read here the toilet, and there is a symbol of gate, the door here. So this is your toilet, this portion is to your toilet, and you can observe here gate, this is your gate, and this wall is there on which one door is there. This is that door, and this portion here is the living room, and this is the living room. This is the bedroom, and here in the plan it is here the kitchen. The plan is actually the top view of this home. The top, in civil engineering terms, the top view is called the plan, P-L-A-N, plan. So this is the plan. You might have heard the word plan if you have been to some construction sites. One more time, the top view of this 3D model is called the plan, and it will be given by the civil engineer. Just by seeing this paper, anyone from this architectural side or the construction side can easily identify, can easily imagine this home. So if you are seeing for the first time this plan, you would not be able to imagine this shape. But as we go along, as we learn the engineering drawing, then the surveying. If you are a civil engineer, you are going to learn surveying and all that. But if you are from other fields like mechanical or electrical, computer science engineering, you will not come across this plan. But this is in general, this is one of the application of engineering drawing. So from these two examples, we see that engineering drawing is a very important subject, and it covers wide range of applications in diverse fields. So it becomes very important for us to learn the rules of engineering drawing. One important thing here, that manual drafting is not in use nowadays. Like it's not been in general use. Most of the times, practically we are using modeling softwares like AutoCAD, Revit, MEP, and SolidWorks, CATIA for the specific applications. But we have to learn first manual drafting techniques on the drawing sheet, by which way we are going to do this course, so that afterwards it will become easy for us to learn AutoCAD, Revit, SolidWorks in the future. So this course is limited to manual drafting, but once you are done with the manual drafting, once you know how to use the drafter, and once you know the rules of engineering drawing, the dimensioning rules and the rules to draw orthographic projections, it becomes very easy for you to learn AutoCAD, Revit and other modeling softwares. So that is why it's very important to learn engineering drawing. Thank you.